Next example is R2 over R is vector space. All of you know about R2. R2 is a R cross R. That is our plane. Our Cartesian coordinate plane. We can call it as Cartesian coordinate plane. So, all elements of R2 is like this, xy coordinate pair such that x is an element of R, y is an element of R. So, R2 can be written as set of xy such that xy is an element of R. This is okay. Next, we need to prove that R2 over R is vector space. So first we need to say V is R2 and F is R. So we need to prove first property, associative property. We take three elements from R2. So x1, y1, x2, y2, x3, y3 is an element of R2. These three elements are from R2. x1, y1 plus x2, y2 plus x3, y3. So associative property means we take three elements in one set and second and third elements adding after first element add, that is equal to first two elements adding after third element adding. That both operations are equal. So here we take first element is alone and second and third. First we adding second and third and after first element is adding. So we take x2 plus x3, y2 plus y3, coordinate addition. x1, y1. That is equal to x1 plus x2 plus x3, y1 plus y2 plus y3. Next we need to prove that first we need to prove that x1 plus y1 plus x2 plus y2 equal to plus x3 y3 equal to x1 y1 plus x2 y2 plus x3 y3. We need to prove that this first two elements adding and last element add, last two elements adding and first element add. These both are equal. So here we add last two elements and after first element we get x1 plus x2 plus x3, y1 plus y2 plus y3. We know x1, x2, x3 are in R and y1, y2, y3 are in R. So here x1 plus x2 plus x3 is a addition of R. So we know that addition of R is associative. So we can write x1 plus x2 plus x3. Similarly, this also addition of R, that is associative. So we can write y1 plus y2 plus y3. Then after we will split these two additions, we get x1 plus x2, y1 plus y2 plus x3, y3. We can write x1, y1 plus x2, y2 plus, also we split these two but we take a pair plus x3, y3. So we get these both are equal. This left side we will take x1, y1 plus x2, y2 plus x3, y3. We got x1, y1 plus x2, y2 plus x3, y3. So R2 is associative. Similarly, we take two elements R2, x1 plus x2 equal to x1, y1. So x1, x2, y1, y2. So we need to prove that commutative. So we take x1, y1. Next we need to prove that R2 is commutative. So we take x1, y1, x2, y2, two elements from R2 and adding we get coordinate wise addition. So we get x1 plus x2, y1 plus y2. So we know x1 and x2 from R, y1 and y2 from R. So x1 plus x2 is commutative. Similarly, y1 plus y2 is commutative. So we write x1 plus x2 plus x1, y2 plus y1. After we can split coordinate wise x2 plus x2 y2 plus x1 y1. So x1 y1 plus x2 y2 equal to x2 y2 plus x1 y1. So commutative. Similarly, next is 0. Existence of 0 vector. 0, 0 is an element of R2. Any element xy plus 0, 0 equal to xy. So 0 vector is also exist in R2. So third property also satisfied. Next, inverse. Any element xy is an element of R2. We need to prove that it has inverse in R2. So how to find inverse? Inverse is xy plus minus x minus y equal to identity 0 vector. So we will say the inverse of this element is this. Inverse of xy is minus x minus y. So we got inverse of xy is coordinates is an minus x minus y is an element of R2. So inverse also exists in R2. Next we need to prove that identity element. Multiplicative identity. Multiplicative identity means V is an element of V. So we take xy is an element of V. Next 1 1 xy equal to 1 1 equal to sorry not this one. We need to prove that multiplication. Yes. 1 1 x1 x2 equal to 1 x1 1 x2. Therefore, this also x1 x2. So multiplicative identity is also exist. Next we need to prove that distribution. So R over R. So alpha is an element of R and U can be written as x1 y1, V can be written as x2 y2. So alpha into U plus V, x1 y1 plus x2 y2 can be written as alpha x1 plus x2 y1 plus y2. That is equal to alpha x1 alpha x2 comma alpha y1 alpha y2. That can be written as alpha x1 alpha x1 comma alpha y1, alpha x1 comma alpha y1 plus alpha x2 comma alpha y2. We take separation alpha x1, alpha y1, alpha x2, alpha y2. So alpha x1 comma alpha y1 plus alpha x2 comma alpha y2. So alpha x1 y1 plus alpha x2 y2. So we get a distribution of scalar multiplication. Next, alpha beta is an element of R and xy is an element of R2. Alpha plus beta xy equal to alpha xy plus beta xy. We can write alpha into V plus beta into V. That's alpha xy plus beta xy. That is equal to alpha x alpha y plus beta x beta y. That is equal to alpha x plus beta alpha y plus beta x plus beta y. Next, we can split alpha x comma y. Okay, here we can write alpha beta x comma alpha beta y. So alpha xy, alpha x comma beta x. Okay, we get alpha xy plus beta xy. So that also satisfied. Next is alpha beta is an element of R. V equal to xy is an element of R2. We get alpha into beta xy equal to alpha into beta x beta y. That is equal to alpha beta x comma alpha beta y. That is equal to, we can pair it, alpha beta x from R. So these are associative. So we can pair alpha beta into x. Similarly, alpha beta y is in R. So we can pair alpha beta y. So we can write alpha beta x comma alpha beta y. Alpha beta in common. So we can outside alpha beta xy. So we get alpha beta xy equal to alpha beta xy. Therefore, 8 properties are satisfied. We get R2 over R is vector space.